An explosive Mother Nature moment caught on camera at Yellowstone National Park. The park's Black Diamond Pool burst with a sudden and muddy eruption captured by U.S. Geological Survey cameras that posted at the site. The video was then shared on social media.
For millions of years, something the size of a small state has been quietly breathing beneath Yellowstone National Park. It has buried much of North America in ash, carved out a crater nearly 30 miles wide, and still releases enough heat every day to power several nuclear plants. So when scientists announced they had detected an entirely new change beneath Yellowstone in the summer of 2026, the internet exploded. The deeper researchers investigate this sleeping giant, the more they uncover a world of shifting magma, hidden underground rivers, mysterious explosions, and geological forces powerful enough to reshape an entire continent. And now, with the internet abuzz with news and rumors of how scientists just detected a new change beneath the Yellowstone Supervolcano, how scared should we all be? To make sense of it all, let's start from the very beginning. The monster beneath America. Yellowstone's violent history. Most people think Yellowstone is just America's oldest national park, famous for Old Faithful, roaming bison, and colorful hot springs. But beneath those postcard views, hidden several miles underground, is one of the largest active volcanic systems on Earth. This vast network of magma reservoirs, superheated rock, and underground plumbing has shaped an entire region of North America. It is so immense that scientists can track its fingerprints across multiple states, and it has been rewriting the landscape for millions of years. That is why every unusual tremor, every shifting geyser, and every crack in the ground inevitably reignites one haunting question. What happens if the giant beneath Yellowstone ever wakes up again? The story actually begins long before Yellowstone itself existed. Roughly 16 to 17 million years ago, a plume of unusually hot rock rising from deep within Earth's mantle began burning through the North American continent. Unlike most volcanoes, the hot spot barely moved. Instead, the North American tectonic plate slowly drifted southwest over it, like a conveyor belt passing above a stationary blowtorch. As the continent moved, the hot spot carved an almost perfectly traceable scar across southern Idaho, leaving behind a chain of enormous ancient calderas that today form the Snake River Plain. Each massive eruption marked another stop along the hotspot's journey until, about 2 million years ago, it arrived beneath what is now northwestern Wyoming. That was when Yellowstone's story truly began. Its first act was almost beyond comprehension. Around 2 million years ago, the Huckleberry Ridge eruption expelled roughly 2,450 cubic kilometers of volcanic ash, pumice, and molten rock, enough material to bury entire countries beneath hundreds of feet of debris. Ash from that eruption has been discovered from Southern California to the Gulf of Mexico, offering a glimpse of just how enormous the blast really was. Had an eruption of that scale occurred today, it would rank among the greatest natural disasters in human history. Entire communities surrounding Yellowstone would likely be destroyed by pyroclastic flows. Thick ash could blanket much of the western United States. Air travel across North America would grind to a halt. Global temperatures could fall for years as sulfur aerosols blocked sunlight, and worldwide food supplies and economies would come under extraordinary strain. Astonishingly, this would not be Yellowstone's only super-eruption. Around 1.3 million years ago, the Mesa Falls eruption reshaped the region again, followed by the Lava Creek eruption approximately 631,000 years ago. That third eruption created the enormous Yellowstone caldera visitors unknowingly drive across today, stretching roughly 30 by 45 miles across northwestern Wyoming. Now you may think that it erupted 3 times, and then somehow went quiet. In reality, the volcano never stopped evolving. After the Lava Creek eruption, molten rhyolite continued forcing its way toward the surface, producing dozens of comparatively smaller lava eruptions over hundreds of thousands of years. The youngest of these occurred roughly 70,000 years ago, forming features like the Pitchstone Plateau. These eruptions lacked the explosive violence of the earlier super-eruptions, yet they prove Yellowstone has remained volcanically active throughout much of recent geological history. Yellowstone remains one of the most intensely monitored places on Earth, precisely because scientists refuse to rely on assumptions. Hundreds of seismometers, GPS stations, satellite measurements, gas sensors, and thermal instruments constantly watch for even the slightest changes beneath the park. Every earthquake swarm, every inch of ground uplift, and every shift in geothermal activity adds another piece to a puzzle researchers are still trying to solve. The monster beneath America is very real, and its history is among the most violent our planet has ever witnessed. Yet catastrophe is not inevitable tomorrow. Earth's most powerful forces operate on timescales so vast that humanity has witnessed only the closing moments of a story that began millions of years before our times. But what if the worst does happen? Can we say for a fact that it wouldn't? A volcano that never sleeps. If Yellowstone were a person, doctors would call it restless. It never truly stops moving. Even on days when millions of tourists stroll safely past steaming pools and erupting geysers, the ground beneath them is quietly shifting, stretching, and breathing. The changes are usually so subtle that nobody notices them without scientific instruments, but they never really stop. The unsettling part is that almost everything happening beneath Yellowstone today would sound alarming anywhere else on Earth. Here, it's simply another day at one of the world's most closely monitored volcanic systems. Take earthquakes, for example. Most people only hear about Yellowstone when a swarm makes headlines. But the truth is, the park experiences them almost continuously. Every year, scientists record somewhere between 1,000 and 3,000 earthquakes beneath Yellowstone. Most are so small that visitors never feel them, often measuring less than magnitude 2. What really catches researchers' attention are earthquake swarms, periods when dozens or even hundreds of earthquakes occur within hours or days, without one dominant main shock. Yellowstone experiences these swarms regularly, and while they can look dramatic on seismic maps, they usually reflect underground fluids shifting through cracks in the crust rather than magma racing toward the surface. Some swarms have included more than 1,000 tiny earthquakes, only to fade away without triggering anything larger. As strange as the earthquakes are, the ground itself behaves even more mysteriously. Scientists have discovered that Yellowstone's enormous caldera rises and falls almost like a slow, steady heartbeat. High-precision GPS stations and satellite radar have revealed that entire sections of the park inflate as magma, hot water, and volcanic gases accumulate underground, then gradually sink again as pressure eases. One of the most remarkable episodes occurred between the early 2000s and around 2010, when parts of the caldera rose by nearly 10 inches before slowly reversing direction. To put that into perspective, an area spanning hundreds of square miles quietly lifted itself toward the sky without most visitors realizing anything had changed. The movement was not caused by an impending eruption, but by the enormous underground system continuously adjusting itself, proving that Yellowstone's landscape is anything but fixed. That restless behavior extends all the way to the surface, where Yellowstone hosts one of the greatest collections of geothermal features on the planet. Scientists estimate the park contains roughly 10,000 hydrothermal features, including hot springs, mud pots, fumaroles, and steaming vents. Even more astonishing, Yellowstone contains more than half of all the active geysers found anywhere on Earth. Every one of those features depends on an intricate underground plumbing network carrying heated groundwater through countless fractures, chambers, and mineral-lined conduits. Researchers understand the broad mechanics behind these systems, but the finer details remain surprisingly mysterious. Tiny shifts in underground pressure can cause one geyser to stop erupting, while another suddenly becomes more active. Entire hot springs have appeared almost overnight, while others have vanished just as quickly, reminding scientists that Yellowstone's hidden plumbing is constantly rearranging itself beneath their feet. Perhaps no feature demonstrates that unpredictability better than Steamboat Geyser. Located in Norris Geyser Basin, it is the tallest active geyser on Earth, capable of blasting water more than 300 feet into the air. For decades, however, Steamboat behaved almost like a sleeping giant. It erupted only sporadically, sometimes remaining quiet for years. Then, beginning in 2018, something changed. Without warning, the geyser entered an extraordinary period of renewed activity, erupting dozens of times each year and shattering modern records. Scientists immediately began searching for explanations. Some suspected subtle changes in groundwater pathways, while others wondered whether shifting underground pressures had reopened blocked conduits. Despite years of study, no single explanation fully accounts for the dramatic increase. It remains one of Yellowstone's most intriguing, unsolved mysteries. All of this activity is fueled by an almost unimaginable amount of energy escaping from deep underground. Yellowstone continuously releases an estimated 4 to 6 gigawatts of thermal energy into the environment, roughly equivalent to the output of several large nuclear power plants operating around the clock. That heat powers the colorful hot springs, feeds the boiling mud pots, drives the geysers, and warms thousands of underground water channels simultaneously. Every puff of steam rising into the cool Wyoming air represents heat that has traveled upward through miles of rock from Earth's interior. Yet despite this incredible energy output, most of it dissipates harmlessly into the atmosphere. That is what makes Yellowstone so fascinating and so unnerving. Nearly every fact about the volcano sounds like the opening chapter of a disaster. Thousands of earthquakes every year, giant sections of the ground rising and falling, the world's greatest concentration of geysers, underground plumbing that scientists still cannot fully map, heat equal to multiple nuclear power stations continuously escaping from below. Taken individually, any one of those facts would seem extraordinary. Together, they paint the picture of a volcanic system that never truly rests. The discovery that started the panic. In the summer of 2026, scientists witnessed a chain of events unlike any previously documented so closely in the park's history. The discovery was unsettling because it exposed just how little scientists still know about one of the most unpredictable hazards inside the park. And the fact that they happened to capture the event with an unprecedented array of monitoring instruments transformed an ordinary geological incident into one of the most important scientific opportunities Yellowstone has ever offered. To understand why, however, we first need to leave the internet rumors behind and travel back nearly 2 years to a quiet geothermal basin northwest of Old Faithful. On July 23, 2024, visitors gathered around Black Diamond Pool in Biscuit Basin, expecting nothing more dramatic than bubbling hot water and drifting steam. Instead, shortly before 10 o'clock that morning, the ground erupted with astonishing violence. A massive hydrothermal explosion launched boiling water, mud, rocks, and steam somewhere between 400 and 600 feet into the air. Huge chunks of debris crashed back down across the surrounding landscape, while sections of the wooden boardwalk were ripped apart as though they were made of matchsticks. Video captured terrified tourists running for safety as clouds of steam engulfed the basin. Miraculously, no one was killed or seriously injured. Investigators later concluded that the explosion occurred just moments after visitors had moved away from the immediate area. The explosion immediately changed the way scientists viewed Biscuit Basin. Unlike a volcanic eruption driven by rising magma, this had been a hydrothermal explosion caused by superheated groundwater trapped beneath the surface until pressure suddenly overwhelmed the surrounding rock. The event left researchers with a troubling realization. These explosions could happen with little warning in areas visited by millions of people every year. As a result, the Yellowstone Volcano Observatory expanded monitoring around the basin. New instruments, including seismometers, temperature sensors, infrasound microphones, and high-resolution cameras were installed during the following months. At the time, few imagined those instruments would soon witness another extraordinary event. Then came June 13, 2026. Before dawn, monitoring equipment suddenly detected an unusual burst of seismic energy accompanied by low-frequency infrasound signals. At first, scientists naturally suspected Black Diamond Pool had exploded again. After all, It had become the obvious troublemaker inside Biscuit Basin. But when they examined the temperature data, something didn't fit. Sensors inside Black Diamond Pool showed only modest changes. If the famous pool had been the source, temperatures should have surged dramatically. The evidence pointed somewhere else entirely. Cameras soon revealed the answer. Instead of Black Diamond Pool erupting again, the ground beside it had literally torn open in a location that had never displayed any remarkable activity before. When geologists reached the site, they found something even stranger. 3 entirely new hydrothermal vents had appeared where solid ground had existed only hours earlier. A fresh fracture stretched through the earth for more than 60 feet, opening in places to nearly 5 feet wide. Near boiling water poured from the new vents and flowed downhill toward the Firehole River, carrying enormous quantities of gray sediment with it. The explosion itself had been relatively small compared to the dramatic 2024 blast. But what happened next astonished researchers. The story was only beginning. Over the following days, the ground continued changing. Instead of stabilizing after the explosion, part of the surface quietly collapsed inward. A brand new boiling pool formed where there had previously been dry ground, not because another explosion blasted material outward, but because the Earth itself simply gave way into the hot hydrothermal system beneath it. Then, only days later, the new pool began erupting on its own, sending boiling water dozens of feet into the air during repeated spouting episodes. Scientists had observed hydrothermal explosions before, but they had never watched an entirely new geothermal feature form through collapse and then evolve into an active erupting pool within days. The newly installed monitoring station stood only about 100 meters away, making this the closest a hydrothermal explosion had ever occurred to dedicated scientific instruments in Yellowstone. For the first time, researchers possessed synchronized seismic recordings, infrasound data, temperature measurements, and high-resolution video capturing nearly every stage of the event. Previous hydrothermal explosions had largely been reconstructed after the fact from damaged ground and scattered debris. This time, scientists had front-row seats. That brings us to the question researchers are still trying to answer today. Did those instruments detect subtle warning signs before the explosion? Signals so faint they had never been recognized before? Or did the ground remain completely quiet until the very instant it failed? The answer could reshape how scientists monitor hydrothermal hazards around the world. But it is important to understand the facts. The truth behind the headlines. The latest activity highlighted a completely new, different hazard, one that receives far less attention despite posing the greatest immediate threat to visitors inside the park. That hazard is known as a hydrothermal explosion, and despite occurring inside one of the world's largest volcanic systems, it has surprisingly little to do with a volcanic eruption itself. A true volcanic eruption is driven by magma forcing its way upward through Earth's crust. A hydrothermal explosion, by contrast, is driven by water. Yellowstone's geothermal basins are filled with groundwater that seeps deep underground, where it is heated by hot rocks surrounding the magma system. As that water circulates, it dissolves silica from the surrounding volcanic rock. Over thousands of years, the silica gradually hardens into dense mineral deposits that line underground fractures and channels. Eventually, those mineral coatings become so thick that they effectively seal portions of the underground plumbing network, trapping enormous quantities of superheated water beneath an almost impermeable cap. Think of it as an enormous underground pressure cooker. The trapped water remains in liquid form only because the immense pressure prevents it from boiling, even though its temperature may be well above the normal boiling point. Meanwhile, heat continues flowing upward from deep beneath Yellowstone, steadily increasing the pressure inside these sealed chambers. Everything remains perfectly stable until the rock above weakens just enough, perhaps because of tiny earthquakes, shifting groundwater, or natural cracking. Then, in a fraction of a second, the seal fails. Pressure drops almost instantly. The superheated water flashes explosively into steam, expanding hundreds of times in volume. That violent expansion blasts rocks, mud, and boiling water into the air, or causes the weakened ground above to collapse into the empty cavity below. From the surface, it looks remarkably like a volcanic explosion. Underground, however, the mechanism is entirely different. That distinction is why the United States Geological Survey repeatedly emphasizes that hydrothermal explosions represent Yellowstone's greatest immediate natural hazard. They can occur with little or no obvious warning, often in areas where visitors walk every day, unlike a major volcanic eruption, which scientists believe would almost certainly be preceded by months or even years of escalating geological unrest. Hydrothermal explosions can develop from shallow processes occurring only a few hundred feet beneath the surface. The dramatic explosion at Black Diamond Pool in July 2024 demonstrated exactly how dangerous they can be. Debris was hurled hundreds of feet into the air, destroying boardwalks that tourists had occupied only moments before. Had the timing been slightly different, the outcome could have been catastrophic. Perhaps the most astonishing evidence of these explosions lies hidden beneath Yellowstone Lake. There, along the northern shoreline, sits Mary Bay, the largest known hydrothermal explosion crater on Earth. Measuring roughly 1.5 miles across, the enormous crater formed around 13,800 years ago, shortly after the last ice age. Scientists believe an immense hydrothermal explosion suddenly excavated the crater, ejecting massive quantities of rock and sediment into the surrounding landscape. Some researchers have suggested that powerful earthquakes occurring as glaciers retreated may have destabilized Yellowstone's underground plumbing, triggering the blast. However, the exact cause remains uncertain. Whatever happened, Mary Bay demonstrates that hydrothermal explosions are capable of producing truly enormous geological changes without requiring a volcanic eruption at all. Even more surprising is the frequency with which these events have occurred. Geological studies have identified evidence for more than 20 major hydrothermal explosions across Yellowstone since the end of the last ice age. Many left behind craters, shattered rock deposits, and altered geothermal systems that remain visible today. Smaller explosions happen much more often, sometimes every year, somewhere within the park. Yet because they are localized and relatively short-lived, they rarely receive the attention given to sensational predictions of a super-eruption. Ironically, the threat people fear least is often the one scientists spend the most time trying to understand. Meanwhile, Yellowstone's official volcano alert level remains normal for now, while the aviation color code remains green. Earthquakes continue to occur within their long-established background levels. Ground deformation remains consistent with the slow inflation and subsidence observed for decades. Gas emissions show no evidence of rapidly ascending magma, and recent hydrothermal activity fits well within the behavior expected from Yellowstone's constantly evolving geothermal system. But what if this changed? How horrible would that fateful day be? If Yellowstone ever truly woke up, it will not happen tomorrow, not next year, but that day will come for sure in the distant future. Every volcano that remains active eventually erupts again. Yellowstone is no exception. The uncertainty isn't whether another eruption will happen. The uncertainty is what kind of eruption it will be. It could produce another relatively modest lava flow, similar to the dozens that have occurred since the last super-eruption around 70,000 years ago. It could unleash a moderate volcanic eruption that affects the surrounding region. Or, in the most extreme case, it could produce another caldera-forming super-eruption unlike anything humanity has ever witnessed. That last possibility is what transformed Yellowstone into a household name. A true super-eruption is classified as a volcanic explosivity index, or VEI 8 event, the highest category on the scale. The last time Yellowstone produced one was the Lava Creek eruption roughly 631,000 years ago. Scientists estimate it expelled around 1,000 cubic kilometers of volcanic material, while the even older Huckleberry Ridge eruption released more than twice that amount. Those numbers are almost impossible to visualize. Imagine Mount St. Helens in 1980, then multiply its erupted volume hundreds of times over. The explosion would not simply blast upward, it would fundamentally reshape the landscape itself. collapsing the ground as enormous magma chambers emptied beneath the surface. The destruction would begin closest to the volcano. Within minutes, colossal pyroclastic flows, which are fast-moving avalanches of superheated gas, volcanic ash, and rock fragments, would race outward from the collapsing eruption column. These flows can travel at highway speeds exceeding 100 miles per hour, while reaching temperatures of several hundred degrees Celsius, incinerating forests, rivers, wildlife, and virtually everything else in their path. During Yellowstone's ancient super-eruptions, pyroclastic deposits accumulated hundreds of feet thick across large portions of the surrounding region. Anyone caught within that zone would have virtually no chance of survival. Fortunately, scientists also emphasize that such an event would require unmistakable geological warning signs long before these deadly flows ever formed. Above the collapsing caldera, the eruption column itself could become one of the largest ever witnessed on Earth. Models suggest ash and volcanic gases could be blasted between roughly 20 and 30 miles into the atmosphere, penetrating the stratosphere where weather systems cannot quickly wash the material away. Depending on the size of the eruption, hundreds or even thousands of cubic kilometers of ash could be ejected into the sky. Prevailing winds would then determine where much of that material ultimately fell. Thick ash deposits could blanket large parts of the western USA, while finer volcanic ash might spread across much of North America. Geological evidence from Yellowstone's previous super-eruptions shows that ash reached as far as the Gulf of Mexico and has been identified in sediments across much of the continent. Contrary to popular imagination, volcanic ash is not soft fireplace ash. It consists of microscopic fragments of volcanic glass and pulverized rock with razor-sharp edges. Even relatively thin accumulations can cause widespread damage. Heavy ashfall can collapse rooftops under its weight, clog engines, destroy electronics, contaminate drinking water, and strip leaves from crops. Livestock would struggle to graze as ash blanketed fields, while water treatment plants would face enormous challenges filtering abrasive sediment. Power grids could fail as ash created electrical short circuits across transmission systems. Highways would become nearly impassable, not only because of poor visibility but because volcanic ash rapidly destroys vehicle engines. Aviation would face one of its greatest crises in modern history. Jet engines ingesting volcanic ash can fail catastrophically, forcing airspace closures across huge portions of North America for weeks or even months. Yet the effects would not stop at the continent's edge. One of the greatest global threats from a super-eruption comes not from ash, but from sulfur dioxide injected high into the stratosphere. There, the gas reacts to form sulfate aerosols that reflect incoming sunlight back into space. Scientists believe this process could trigger a volcanic winter lasting several years by lowering average global temperatures. The growing seasons would also be shortened across multiple continents. Similar but much smaller eruptions, including Mount Pinatubo in 1991, temporarily cooled Earth's climate by roughly half a degree Celsius. A Yellowstone-scale super-eruption could produce a far larger effect. Crops would fail in vulnerable regions, food prices would soar, and international supply chains could collapse under simultaneous agricultural and transportation crises. Economic losses would almost certainly be measured in trillions of dollars, making it one of the costliest natural disasters in human history. This is where Hollywood often departs from science. Disaster movies frequently depict Yellowstone splitting North America apart, oceans boiling, continents shattering, or humanity disappearing overnight. None of those scenarios are supported by geological evidence. The North American continent would not explode, the oceans would not suddenly vaporize, Earth would not become permanently uninhabitable. Even a super-eruption, extraordinary as it would be, remains a geological event rather than a planet-ending catastrophe. Human civilization has survived ice ages, pandemics, world wars, and countless natural disasters. It would almost certainly survive Yellowstone as well. However, the cost in lives, infrastructure, agriculture, and economy would be staggering. As horrifying as this is, our story does not end here. The real horror is what scientists still don't know. The most important discovery at Yellowstone in recent years wasn't the new vents at Biscuit Basin. It was the unprecedented data scientists collected. When hydrothermal activity unfolded in June of 2026, the Yellowstone Volcano Observatory already had newly installed instruments positioned only about 100 meters away. For the first time in Yellowstone's recorded history, a hydrothermal explosion was captured at close range using seismic sensors, infrasound microphones, temperature probes, and high-resolution cameras operating simultaneously. That is why scientists reacted very differently from the internet. While viral headlines claimed the supervolcano was waking up, researchers focused on a much bigger question. Can hydrothermal explosions actually be predicted? Until now, scientists have had little opportunity to answer that. Previous explosions were reconstructed after the damage had already occurred. This time, every vibration, temperature change, sound wave, and subtle ground movement was recorded before, during, and after the event. Hidden within that dataset may be warning signals that have never been recognized before. There are now two possible outcomes. In the best-case scenario, researchers identify reliable precursors that appear minutes, hours, or even days before a hydrothermal explosion. Small earthquake patterns, changes in underground water pressure, unusual infrasound signals, or subtle temperature shifts could provide enough warning to temporarily close hazardous areas before an explosion occurs. Such a breakthrough would improve public safety not only at Yellowstone, but also at geothermal regions around the world, including Iceland, Japan, and New Zealand. The alternative is just as important and more unsettling. Scientists may eventually conclude that there were no meaningful warning signs at all, and that the explosion occurred the moment the underground seal failed. If that proves true, it would confirm that some hydrothermal explosions simply cannot be predicted with current technology. That would not mean Yellowstone has become more dangerous. Instead, it would define the limits of even the world's most advanced volcanic monitoring systems. Meanwhile, Yellowstone itself continues to change. Following the events of June of 2026, Biscuit Basin remains closed, while scientists monitor ongoing hydrothermal activity and assess ground stability. The newly formed vents continue releasing heat and water, while the collapse-created boiling pool has become another reminder that Yellowstone's underground plumbing is constantly evolving. Water opens new pathways, mineral deposits seal old ones, and pressure shifts from one location to another. A quiet patch of ground can become tomorrow's hot spring, while a famous thermal feature may gradually disappear. Yellowstone is constantly rebuilding itself from below. Tracking those changes requires one of the most sophisticated volcanic monitoring networks on Earth. The Yellowstone Volcano Observatory, led by the United States Geological Survey with university and federal partners, operates hundreds of instruments, including seismometers, continuous GPS stations, satellite radar, gas monitoring equipment, thermal cameras, and stream gauges. Every earthquake swarm, every inch of ground deformation, every change in gas chemistry, and every shift in geothermal activity is analyzed for signs that magma may be moving upward. Scientists believe that if Yellowstone were truly preparing for a volcanic eruption, they would likely detect months or even years of escalating unrest. But would that really matter in the worst-case scenario? That we cannot answer. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.